Welcome to Unit 4, Lesson 2. So in this lesson, our goals are to find the gradient and intercepts of a line and to find the equation in either standard or slope-intercept form. So in the last lesson, we looked just at the gradient and how to find that. This lesson is going to focus on the full equation, including the gradient and the intercepts. So to be able to accomplish these goals, we first need to review the equation of a line. So the equation of a line is basically something that algebraically communicates the relationship or the connection between the x and y coordinates of any point on that line. So what this really means is a couple of things. One, if a point is indeed on the line, then the coordinates of that point will satisfy the equation. The reverse of that is also true. If the coordinates of any point satisfy the equation, then we can conclude that that point lies on the line. So one important thing to remember is that coordinates are said to satisfy an equation if when you substitute the values into the equation, the two sides of the equation are equal. So it basically makes the equation a true statement. So this is really important because this is something you can rely on to help you solve problems. When we think about the equation of a line, the most common form we encounter is this form here, which is called your slope-intercept form. And it's called the slope-intercept form because it's based on two main pieces of information. M, which is the gradient or the slope, and we learned last lesson how to calculate that, and C, which is the y-intercept. So this is basically the y value of the point where the line crosses the y-axis. So you can see that in this diagram here. This would be your y-intercept. So the C value in your equation is also the y value of that point. So this is really important to remember because you can use this form to problem solve very effectively. So we'll look at some examples to practice using these skills. So in the first example, we're given a graph and we're asked to find the equation. So this is actually not so bad because we only need two pieces of information. The slope, which is your rise over your run, and the y-intercept. So we'll look at the slope first. We can pick any 2 points on the line. So I see a nice point here, and I see a nice point here, and I can look at my rise over run. And the rise over run of this line appears to be 2 because I rise up 2 and I run over 2. So the rise over run is 2 over 2, which means my slope is actually 1. And when I look at the graph, I've clearly marked the y-intercept there, and that occurs at the coordinates 0, 1. So I can combine these pieces of information to create my equation, which I know is in slope-intercept form. I'm going to substitute in the value of the slope, which is 1. So instead of writing 1x, we commonly just write x, and I'll replace c with the y-coordinate of the y-intercept, so that's 1. So the equation of this line is y equals x plus 1. And this kind of fits with some of the things we saw last lesson because I have a positive slope, which means the line should be going upwards, which it is. So that's a nice confirmation for me that I'm on the right track. So that's not so bad, finding the equation from a graph. The next example involves putting into play more of the information we learned at the beginning of this video. So here we're given a point and a gradient, and we're asked to find the equation. So we know that the equation starts in this slope-intercept form, and we're already given a key piece of information, which is that our gradient is 5. So I can actually replace m, which is for the gradient, in the equation to get this. Now, to be able to solve this problem, I need to solve for c. And in order to do that, I can use to my advantage the fact that I'm told a point lies on the line. So this point, I know, lies on the line, 1, 7. And I know that if that's true, then the point must make the equation true. So to accomplish this, I can sub in 1, 7 for x and y. And then I can solve for c. So I'm using to my advantage the fact that I know when a point is on the line, then those coordinate values will satisfy the equation or make it true. So the value of 1 is the x value and 7 is the y value. So I'm going to replace those for x and y in the equation. And that gives me 7 equals 5 plus c. And if I subtract 5 from both sides, I end up with c equals 2. But I'm not actually done yet. So remember it said to find the equation of L. So I can't just stop at the y-intercept. I need to say, therefore, the equation is y equals 5x plus 2. So that's the final answer to my question. And now here's a third part where we're asked to do some similar work. So here's a situation where we're given the gradient and a point again and asked to find the equation. So that's similar to the last one. So we start with our slope-intercept form. We substitute in our gradient, which is 1/3. So the only difference here is now we're working with fractions. And then I know the point, so I can substitute in the coordinates to help me solve for c. So here my y value is -1 and my x value is 2. So I'm going to get -1 equals 2/3 plus c, and c will be equal to -1 minus 2/3. So I'm going to subtract 2/3 from both sides, and then that means that my y-intercept is -5/3. So -3/3 minus 2/3. And that gives me my final equation of 1/3 x minus 5/3. So there's the equation of my line. And when I'm looking for the x and y intercepts, key thing to remember is the x-intercept occurs when y equals 0, and the y-intercept occurs when x equals 0. So that's the sort of definition of the axis intercepts. So if I want to find the x-intercept, I can sub in y equals 0. So that's for the x-intercept. So I can make y equal to 0 in my equation, and then I'll have this equation, and I can just rearrange that to solve for x. So I'm going to get -5/3 equals x/3, or 1/3 x. And if I multiply both sides by 3, these will cancel out, and I'll just get x equals -5. So that's my x-intercept. For the y-intercept, it is true that it's when x equals 0, so I could sub in x equals 0, or I can just remember that it's just equal to the c value. So the y-intercept is at 0 and -5/3. So the x-intercept is, you can also write it as coordinates as -5, 0. So that's how you can use, again, the idea of coordinates and how those relate to the equation to solve for the intercepts. So we'll do one more topic for this lesson, which is equations in general form. So up until now, we've been working in slope-intercept form. There's another form of an equation called general form. And it looks like what we have written here. Ax plus by plus d equals 0. There's some important things about general form to know. No fractions are allowed. So all your values have to be integers, and a must always be positive. So we can do some simple algebra to take a slope-intercept equation to rearrange it into general form. So if we look at the question given here, we're starting with y equals -2/3 x plus 2. So eventually you have to get all the terms on the left side, so you have 0 on the right side, and you have to eliminate fractions. So I'm going to start by eliminating the fractions. And what I can do to accomplish that is I can multiply both sides of the equation, so the entire side, by 3. So that's going to become 3y equals 3 multiplied by this whole side of the equation. I can't just multiply the slope because that would actually change the equation of the line. I need to maintain equality, so I need to do the same thing to both sides. And when this happens, a case for the distributive property comes up. So I have to distribute the 3 to both terms in the bracket here. So I still have 3y. 3 times negative 2/3 just becomes negative 2 because the 3's will cancel out, and 3 times 2 is 6. So I've achieved goal 1, which is to get rid of the fractions. And the next thing I have to do is make sure that all of my terms are on one side. So I'm going to move the negative 2x and the 6 over to the other side. So that gives me positive 2x plus 3y minus 6 equals 0. So that's my final equation, and when I look up here, I get what I was going for, so I know I am correct. So that's how you can rearrange into general form. So we'll try one practice question with this just to wrap up this video. So here's a question where it's giving us 2 points and asking us to find the equation. So this is a nice way to practice all of the skills we've learned in the first and second videos here. So to find the equation, we need the slope. So to calculate the slope, I'm going to use my slope formula, y2 minus y1 over x2 minus x1. So that gives me 2 minus 5 over 1 minus negative 3. Watch your signs, especially when you're subtracting a negative. So that becomes negative 3 over 4. So that's the slope of my line. Now I need to find the y-intercept. I find this easiest to do in slope-intercept form because that's really the only way it's going to work. So I'm going to substitute in my slope, which is negative 3 over 4, and then I'm going to use one of the points from the question to find the y-intercept. So I'm going to use point B here, which is 1, 2. 2 is equal to y, 1 is equal to x. So then I get c equals 2 plus 3/4. So that would be 11 over 4 is the y-intercept. So the equation in slope-intercept form is negative 3/4 x plus 11 over 4. Now I have to be mindful because I was asked for the equation in general form. So I need to do a little bit of algebra here. So I'm going to multiply both sides by 4 to eliminate the denominator in my fractions, because I'm not allowed fractions in general form. And when that happens, I'm going to have 4y. The 4's will cancel out, so I'll get negative 3x. And when I distribute the 4 to 11 over 4, the 4's cancel out again. So I get plus 11. So when I rearrange and move everything over to the left, I get 3x plus 4y minus 11 equals 0. So there's my final equation in general form. So now I'm prepared to move on to part B. So I'm given a point in part B where I have an x value and a y value. Now my y value is unknown, and that's what I'm looking for. So again, I can use the principle that if the point is on the line, the coordinates should satisfy the equation. So you can very easily use this principle with general form equations as well as with slope-intercept form. So my slope-intercept form has fractions, which is just going to make this a little more complex. I'm going to start with my general form equation because it will be easier to accomplish this way. So again, I'm going to substitute in my unknowns. My x value is 5 over 3, and my y value is t. And then I can work through this to solve for t. So here my 3 divided by 3 is 1, so that becomes 1, and this just becomes 5. This is 4t and minus 11. So 5 minus 11 is negative 6. So 4t minus 6 equals 0. I can add 6 to both sides, and I get 4t equals 6, which means t is 6 over 4, but I should reduce that to lowest terms, which is 3 over 2. So when I do some simple substitution in algebra, I can successfully solve the problem. So hopefully you're now comfortable with equations of lines and using points and slopes and intercepts to solve problems.